Right, let's deal with our second problem now. 2.2.2. Again, find dy over dx. Simplification is not required. So, as it stands, this is a fraction, similar to that fraction that we had in the previous example. So, as it stands, this is u on the top, v in the bottom. Okay, so my numerator I'm identifying it as u, which is e to the power x cos x. Right. Now, we've got u is equal to e to the power x cos x. So, u prime, let's differentiate each one individually and then we'll put it together. We're doing this in detail. So, what is the knowledge required in order to differentiate this here? Right, the knowledge required is, if you have y is equal to k e to the power f of x, that's exactly what we have here. E to the power f of x, k is just 1, it's a constant. So then y prime will be k e to the power f of x times f prime x, the derivative of the exponent. However, f of x, let me just write that down. However, my f of x is made up. I'm talking about f of x, I'm talking about this exponent here. Can you see that? However, the f of x is made up of, let's call it p times q, multiplication. I'm just using different letters to identify each term or each function. Alright. So f of x is made up of p times q. So therefore, f prime x, in order to differentiate p times q, that means I'm dealing with multiplication here. So therefore, this would have to be the product rule. You're clear with that? It has to be the product rule. So the product rule is, write down the first, differentiate the second, write down the second, differentiate the first. It doesn't matter what you're calling it, f, g, y, z, you know what I mean? It's just the product rule. So, my f of x, in this case, is x times cos x. You're clear with that? So, f prime x, there's my p, which is x, my q, which is cos x. So in order to differentiate this, I will use a product rule, which is copy the first, differentiate the second. The derivative of cos is minus sine, plus copy the second, which is cos x, differentiate the first, which is 1. Copy the second, differentiate the first. So we've got our f prime x sorted out. Okay, now we can write down this formula. K e to the power f of x, e to the power f of x, the formula is e to the power f of x, which is e to the power x cos x. That means I'm at this stage here now, can you see that? Times f prime times f prime, which we just worked out here. Can you see that? Which we just worked out, which is x times minus sine x plus cos x. You're clear with that? So then I'm just going in detail here for you to understand each part of the problem and how to deal with it, basically. Right. So now we've got that sorted out. Right, there's our working out here. V, well, V is a simple there, 1 plus e to the power x. Let me go and write down the formula one time. So dy over dx, the quotient rule, because we are dealing, the original problem is dealing with a fraction. So the quotient rule is copy the denominator, differentiate the numerator. Minus copy the numerator, differentiate the denominator, all divided by the denominator squared. Okay, that is the quotient rule. Do not mix up. It's always copy the denominator, differentiate the numerator. Minus, copy the numerator, differentiate the denominator, all divided by denominator squared. I've seen students in the test mixing it up. Be careful, do not mix up the quotient rule here. Right, so copy the denominator, which is 1 plus e to the power x. You're clear with that? Copy the denominator, 1 plus e to the power x. Differentiate the numerator, u prime. U prime was the one that we had to work out properly here. Can you see that? So now my u prime, I've already got it here, which is e to the power x cos x times minus sine x plus cos x. So let's copy the denominator, differentiate the numerator. Let me just use a bracket like this. So this is my v, u prime, minus u. What is my u? U is the original numerator, which is e to the power x cos x times v prime. What is v? V refers to the denominator. V prime will be the derivative of the denominator, which is 0 plus. What is the derivative of e to the power x? It's just e to the power x. So that is the numerator, all divided by the denominator, which is 1 plus e to the power x all squared, and that is it. Simplification not required. You must get full marks here because the instruction is simplification not required. So that is method number 1. Right, so now let's deal with method number 2. So, what I've noticed, students like to introduce ln all the time. Because maybe from certain examples where you have e, it's good to introduce ln. But in this case, it's really unnecessary. But what happens if you do introduce ln? Okay, let's see what happens. So if I introduce ln on both sides, so if I introduce ln on both sides, I'm going ln absolute value of the left equal to ln absolute value of the right. And when we're introducing ln, remember absolute value because we are dealing with logs now. Okay, logs cannot be negative. Now, how would I go about doing this? So if I introduce ln, now I want to use my log laws to simplify as far as possible. Okay, otherwise it's pointless using ln. So now, how can we simplify this here? So now I've got a numerator, denominator. Remember, if I have ln of 4 over 2, this is the same as ln 4 minus ln 2. The division changes to subtraction from your log laws. Multiplication changes to addition. So I've got ln of the numerator minus ln of the denominator. You're clear with that? Ln of the numerator minus ln of the denominator. Okay, now, what was the whole idea here? Now let's use a log law again. If I have ln of 4, let's take ln of 4 again. You can always verify this on the calculator, the rule. This 4 can be written as 2 squared. You'll agree with that? 4 is 2 squared. Now, if I have an exponent, I can bring it down, and this is equal to 2 ln 2. So this same rule that I'm applying here, I want to apply it to this N5 problem now. Can you see that? So there's my exponent here. I can bring down the exponent, just like how I brought down the positive 2. I can bring down x cos x, and now I have just ln of e there. Okay, minus ln absolute value 1 plus e to the power x. Now, why is this important to bring down? It's because I now have ln e, and any engineering student knows what ln e is equal to. Ln E is the same as log of 10, which is equal to? 1. Which is equal to 1, exactly. Alright, so that is the whole idea of introducing ln. When you have the base E, it's best. Right, so now, ln E is equal to 1. Now clear what's happening here? Right, so now, I still have my ln on the left hand side. Now I need to differentiate. Now there's nothing more for me to simplify. I cannot bring down this exponent here. There's two terms, they're clear. So this, nothing you can do. This, we simplified. Now it's an implicit differentiation problem. It's implicit differentiation. So therefore, I'm going to go d over dx on the left hand side, and then I'm going to go d over dx on the right hand side. D over dx on the left, d over dx on the right. Alright, why am I writing down d over dx? Because now I'm indicating that I will be differentiating both sides with respect to x. Why, and then y is not the subject of the formula. Yes? 1 plus? Oh, sorry. Why am I writing down 1 plus? X squared is 1 plus e to the power x. Right. So now, d over dx of ln y. The derivative of ln y is going to be 1 over y. And remember, when you differentiate with respect to y, what do you multiply by? dy over dx. So that's my left hand side sorted. Can you see that? Right hand side. This is x times cos x. So in order to differentiate a multiplication problem, what rule do I use? I use the product rule. So this is going to be the product rule. Okay, so the product rule is copy the first, differentiate the second. The derivative of cos is minus sign, plus copy the second, differentiate the first, which is 1. You're clear with that? So that was the product rule. Plus, now I'm differentiating ln there again. And for those of you unfamiliar with the ln formula, remember if I have y is equal to ln f of x, y prime, the derivative is going to be f prime x all divided by f of x. You must know your differentiation 100% here. You can see that. Right, so there's a formula to differentiate ln. So in this case, my f of x is 1 plus e to the power x. So f prime x will be 0 plus the derivative of e to the power x is e to the power x. So that is f prime x all divided by f of x. What is my f of x? 1 plus e to the power x. Problem is 99% solved now. All I have to do is make dy over dx the subject of the formula and it's sorted out. So therefore, dy over dx, in other words, I'm multiplying by y over 1 on the left, so y and y will cancel, and I multiply by y over 1 on the right, and this is what I have, which is minus x sine x plus cos x plus e to the power x all over 1 plus e to the power x. And there's nothing for me to do any further here. If you want to, you can replace y. Let's replace y. What was y? Y over 1 is y. What was y? If you want to get back everything in terms of x. Y was e to the power x cos x all divided by 1 plus e to the power x. And this is minus x sine x plus cos x plus e to the power x all over 1 plus e to the power x. Alright, so that's it. There's nothing more to do here. If you want to, you can multiply inside, but that's all unnecessary. The fact is, we found dy over dx, and this is an alternate method where we are introducing ln on both sides. It's your choice. Every single example, you can introduce ln. It's just that it's unnecessary in most cases. Okay, so that is it.